Hello, today I'm going to demonstrate activity 915. It is called Strive to Derive. For this activity, I had to create my own multiplication array cards and tape up paper onto two dice with different numbers. For one dice, I needed 2 3s, 2 6s, and 2 9s. And for the other dice, I needed 0, 1, 4, 7, 6, and 8. For this activity, basically students will roll the dice, and whatever two numbers they get, they have to figure out what the answer is, or what it multiplies to, and then point out the centimeter grid paper with that multiplication problem, and then students have to figure out two partitions that go along, or two different partitions that you can use to solve that multiplication problem. I would say that this multiplication game would be good for 3rd graders and up. For the higher levels, you would want to focus on higher facts, so like 12s, 13s, 14s, and so on. For this activity, the book suggested to use 3s, 4s, the facts of 3, 4, 6, and 9. So I have the grid paper cut out and the multiplication problems written out in both ways. I could see this activity being used as a station game, but I wouldn't let students play this by themselves right away. I would actually let this game be my station when I have students come see me, and I would introduce them to the game. And after a week or so, if I felt confident that students knew what they were doing, I would let this be its own station, and then I would focus on something else for them. So now I'm going to go ahead and demonstrate what I would have students do with this activity. So after calling a group to my table, I would tell students that we're going to play a game called Strive to Derive. We would be using our multiplication array cards and 2 dice. I would ask one student to help me arrange these cards in different orders so that everyone can see the different numbers. And then after they're all spread out, I would make sure I have every student's attention, and then I would tell them basically the rules of the game. Each student will take turns rolling the dice, and whatever two numbers they get, they have to multiply them and solve it, and then they have to choose the array card, and then they have to think of two partitions that go along with it. I would review what partitions are, which that's basically splitting numbers into smaller units to better solve a problem. The first student who gets 10 points wins. If a student can't think of two different partitions that go along with the 2 dice, then they won't get a point. But if students are able to think of 2 partitions, then they get a point. So now I'm going to go ahead and roll the dice like the students would. So they got 9 and 0, so 9 times 0 is 0. I didn't make a array card for 0. I didn't really know how that would work since there wouldn't be anything there. So I would basically just have students reiterate to me that 9 times 0 or anything times 0 would be 0, and there would be nothing there. And then I guess I would go ahead and let them re-roll. But I guess depending on the group, maybe they wouldn't re-roll twice. That would just be their turn, and the next student would move on. But in this case, we would go ahead and make them re-roll. So now they got 3 and 4. So 3 times 4 equals 12. And then they have to find the array card, which would be this one. And then they need to think of two possible partitions that go along with it. So a student could either say 2 times 5 and 1 times 2, or 3 times 3 and 3 times 1, which would both of those would equal 12, so they would get a point. Again, 9 and 0 is rolled, so I would let the next student go ahead and re-roll. So they got 6 and 0, so we would reiterate that 6 times 0 is 0, and then it would be the next student's turn. We got 1 and 3, so 1 times 3 equals 3, and then there's only 2 partitions that would fit that scenario. Would be 2 times 1 and 1 times 1, and then cat, get down. 1 times 1, or I'm sorry, 3 and 1, 3 times 1. Oh, right here. It's right in front of me and I can't even see it. They would grab this little card. And then we're going to go ahead and roll one more time to demonstrate. 6 and 8. This is more difficult. Or I'm sorry, 9 and 8. 9 times 8 equals 72. And then I would have them find the card, partition card, which is, or the array card, I'm sorry, this one. And then a possible partition would be 7 times 10 and 1 times 2. For the sake of this game, I went ahead and made, I listed out all the different roles for the 3s, 6s, 9s, 3, 6, and 9, and I wrote out all the possible partitions that would go along with the facts. I would maybe have students have a piece of paper where they can work out the different problems, or maybe have a cheat sheet in the little bag with the activity so they can check themselves. And even for the teacher, when you're going over this game, maybe have a cheat sheet if you're not that confident with your facts. As you can see, 6 times 6 has several possibilities, excuse me, and 6 times 8 has several possibilities, and you just never know what students might come up with. Online, they have different ways of array cards. They use symbols instead of grid paper. So I guess it kind of just depends on what you preferably want to use and what your students want to use. Pictures might be easier than centimeter grid paper. So I think that covers everything. Thank you.